Let's put what we've learned about transformations into practice with linear functions. So 6.2, the I can statement is I can perform transformations of linear functions. So we're going to be dealing with all lines today, and the warm-up here says functions make blank when we graph them, so we should have this down by now, make shapes when we graph them, and blank changes the shapes. So and transformations change the shapes. Transformations. All right, now I've got a couple quick arithmetic questions for you here, translating a phrase into a mathematical sentence here. So it says, which one is the best representation of 5 more than 8? Should we do 5 plus 8 or 8 plus 5? Well, if we say 5 more than 8, everybody knows that the answer is 13. And both of these actually give us the answer, but this is the best representation. And let me give you an example why. This is what they meant, and you can see that by doing this next problem. Which one is the best representation of 3 less than 7? Well, if you do 3 less than 7, you have to do 7 minus 3. It's got to be this one. In fact, not only is it the best, it's the only representation of 3 less than 7. So if you haven't seen this before, whenever we say more than something, we're always going to take the second one, we're going to flip the order, and we're going to say 8 plus 5 in this particular case, and this would have to be 7 minus 3. Now, it's not that this gives you the wrong answer in this case, but it does give you the wrong answer if you just write them down in the order and throw subtraction in there. So it's always best to go with what people meant in the expression that they said. So those two are the best way to represent those. Now, we've been practicing transformations with mostly piecewise functions, these little line graphs that go different directions and things like that. Once we learn how to do transformations with those, we really can transfer those skills to transform any type of graph that we come across or any type of function that we come across. And the first one that we're going to deal with that we're going to see all the time are linear functions. Now, we know what linear functions are. They make lines. We've been graphing these for a while. But we're going to take a look at a parent function that looks like this. This is the most basic linear function. So this is f of x equals x, and we're going to say these are the 3 key points that define the line. Now, a line only takes 2 points to define it. We're going to keep track of these 3, and here's why. So if we plug in a -1, we get out a -1. So f of -1 is -1. F of 0, if we put a 0 here, we put a 0 there. So f of 0 is 0. And if we put a 1 in here, we put a 1 right there. So these are the 3 key points. So I'm going to go ahead and graph these. So we start right here at the origin. And then to get to this point, we would go back 1 and down 1. So we're going to go right here. And to get to this point, we're going to go over 1 and up 1. So whatever the x value is, that's the same as the y value. So if we go forward 1, we go up 1. If we go back 1, we go down 1. And I'm going to keep track of these 3 key points because we're going to use these over and over again. These are the ones that we're going to use to get this shape by saying we go back 1 and down 1. That's the first point. We stay right at the origin for that point in the middle. And then we go over 1, we go to the right 1, and then we go up 1. So here's what the graph looks like. All we need to do is hit those 3 points. Remember, it extends forever in both directions, so I'm just going to draw that line right there. Okay, so here are the transformations that we're going to be performing. So we're going to have a number out in front of that function. So this is going to be a vertical stretch or shrink. It could also be a reflection, so keep that in mind. We're also going to have a function, and then we're either going to add or subtract something inside. So remember, if we change the x before we make the shape, that's going to do a horizontal change. So in this case, it's going to be a horizontal shift. And then if we make the shape and then add or subtract something outside, that's going to be a vertical shift. So we're only going to deal with those 3. Those are the most common ones. They're the basic ones. They're also the easiest ones to do. Now, we may do a combination of these, so keep that in mind. But we're going to come down here and we're going to take a look, and it says describe the transformation, sketch the graph of each transformation, mark and label key points. So this one says f of x equals 2x. So I've got these 3 key points up here right now. So think about what happens here. This is going to be a vertical stretch. We're multiplying by 2. We've got the x right here. We didn't add or subtract anything with that. So we're going to multiply this by 2. So I'm going to write down vertical stretch. The values are twice as tall as they used to be. So what we're going to do here is we're going to take these points, which would normally be we stay at 0, and then if we make that point twice as tall, that doesn't change anything. If we normally go back 1 and down 1, we would go back 1, but we're going to go twice as far in the y direction. Remember, we're making a vertical stretch here, so we would go to about right there. And then we would normally go up over 1 and up 1. We're going to go over 1 and we're going to go up twice as far, so we get this. So our graph looks something like this. And if you've got a nice straight edge or something where you can draw a nice line, nice straight line looks like that. Now, like we did before, I'm also going to come over here and I'm going to put a dotted version of the original one. The original one was just the line y equals x, and it looks like this. Okay? So we're going to run through here, nice 45-degree angle. And what I'd like you to look at is, look at how steep the graph is now. Once we made these points twice as tall, here's another one, twice as tall, here's another one, twice as tall. Okay, here's another one where we went twice as far from the x-axis, twice as far from the x-axis here. So what happens is the graph is steeper than it used to be. It's twice as steep as it used to be. So I'm going to write twice as steep as it used to be here. So the y values are twice as tall. That makes it twice as steep as it used to be. All right, let's take a look at this next one. Notice again that we're not adding or subtracting here, so we've got the shape x, that plain old graph that we had up here, and we've got a 1/2 out in front here. So what that's going to do is that's going to be a vertical shrink. Vertical shrink on this one. So it's going to make the y values half as tall as they used to be. So instead of going to over 1 and up 1, we're going to go over 1 and we're going to go up half as far. 0, 0, you can't be any shorter than 0. You can't be half as tall as 0, so that's just going to be 0. We would normally go back 1 and down 1. We're going to go back 1 and we're going to go down half as far, so we're about right there. So this is what the graph would look like. So we're going to run right along here like this. So we're going to go from here all the way to there, and if you've got a nice straight edge, that might be helpful, but that looks pretty good. So there's the new graph, and then again, I'm going to come in here and I'm going to draw the original one. The original one is that nice 45, so it's just going right like this. And you can see that what's happened here is we have vertically shrunk this. The values are half as tall, and what that does is instead of being as steep as this one, the graph is half as steep as it used to be. So I'm going to write the word half right here. So we've got a vertical stretch, it's twice as steep, twice as tall. We've got a vertical shrink, it's half as tall, it's half as steep as it used to be. And then we'll take a look at this next one. Now we've got a negative in front of the x. So what's going to happen here is we've got that, and we're going to multiply the x by a negative. We're going to multiply the function value by a negative. So this is going to be a vertical flip. Vertical flip here. So here's what we've got. Instead of going over 1 and up 1, we're going to go over 1 and we're going to go down 1 instead. We're going to be at 0, 0, because if you're on 0, you can't go up or down from there if we flip that. And then instead of going over and down, we're going to go over and up, and it's going to look like this. So we're going to draw that line right there. Again, nice and straight as we possibly can, arrows on the end. And then I'll come through here, and again, we'll draw this nice dotted line so we can see the original one. So here's the original function, and here's what happens when we do a vertical flip. So what happened here is we flipped this across the x-axis, So when we're multiplying the y values, the function values that come out by a number, so this one used to be 4, 4, when we multiply it by a negative, when we multiply it by a negative, instead of going over 4 and up 4, we're going to go over 4 and we're going to go down 4. So it changes the value of the y coordinate. And I'll admit it does seem a little bit weird that we're going to do a vertical flip, and yet that's going to reflect it across a horizontal axis, the x-axis right here. But remember, this is the line of symmetry, and what we're doing is we're taking what used to be on the bottom and flipping it on the top, and what used to be on the top and flipping it on the bottom. Okay, let's come down here and take a look at the last one on this page here. It says, describe each transformation, then sketch the graph, mark the key points. So let's see here. We've got x plus 3, so we've got the original function right here, and then we're adding 3. There aren't any parentheses on here. So this is going to be a vertical shift. So I'll write vertical shift. And let's write down what this does. This actually moves it up 3. So we're going to take that standard shape right here that looks like these 3 points, and then all the points that go through, or all the line that extends through those. And we're going to take each one of those and we're going to move them up 3. So we're going to move this up 3 units right here, And then we're going to go over 1 and up 1. We're going to go back 1 and down 1. So we've got those 3 points right there. And so we get something that looks like this. And again, the original one would be this guy right here. And I'm going to come over here and we'll graph this same one over here because I've already got the blue pen out. And let's do this one. This one is parentheses and x plus 3. So you'll notice that it's inside the parentheses, so that's going to do the opposite of what we'd think. So this is going to be horizontal first of all, horizontal shift. And I'm just going to abbreviate this right here, horizontal shift. Save a little bit of room right here. And remember, this does the opposite of what you'd think. So adding 3, you would think it would move to the right horizontally. It's not. It's going to move it to the left 3. So let's take this normal shape right here. That normal shape again was these 3 points, those 3 key points right here. And we're going to take this and we're going to move it left 3. So we're going to go 1, 2, 3. And then we're going to go over 1, same shape, up 1, back 1, and down 1. So it will look like this. So I'm going to go ahead and draw that line right there. Okay? So what do you notice about these two transformations? Well, they end up being exactly the same. So they make the same final shape. They end up in the same place. Okay? Now, how is this like the warm-up problem of 5 plus 8 or 8 plus 5? We had that choice about what's the best way to write 5 more than 8. Well, it's this one right here. Here's the idea. Although we ended up in the same place, we end up with this graph right here. This has a slope of 1 and it crosses the y-axis at 3. This one has a slope of 1 and it does cross the y-axis at 3. Although we end up at the same place, they did mean different things when they wrote this down. So sometimes it can be hard to tell which is which. The fact that this had parentheses on it made this so that this was a horizontal shift. We took it over here and we moved those 3 key points right here. The fact that this was outside the set of parentheses means we make that shape and then we're going to move it up 3 units. The net effect is the same, but we want to make sure that we understand this. So I'm going to go ahead and write down, well, both end up with the same shape. Both end up with the same shape. The same shape, comma, but they arrived there differently. So we'll say they got there differently. And that is totally okay. It's okay if we end up with the same shape as long as we follow what they meant. So again, it's better off to go with what they meant. In this case, they meant 5 more than 8. It would have been this one right here. In this case, even though we know we end up with the same graph, it's better to think of this as a horizontal shift. So we're taking those 3 key points and moving them over here. And in this case, we're thinking of it as a vertical shift. We're taking these 3 key points and then we're sliding them straight up. So sometimes it's hard to tell, but it's a really good thing to be aware of, the difference between a horizontal shift and a vertical shift, and always go with what they meant. Okay, let's take a look at the other side. All right, on this side, we're going to be performing more than one transformation at the same time. So it's going to be important that we make the correct shape first. In other words, do any stretches or shrinks or flips for that matter, and then take it and move it where it needs to be. So we're going to do the shift second. So let's take a look at this. It says, describe the transformation and sketch the graph of each transformation. Mark the key points. So on this one, let's take a look here. So we've got that regular old shape here. We've got that linear function, and then we multiply it by 2. So what this does is this is a vertical stretch. Vertical stretch, okay? Twice, let's just say twice as tall. And then this right here, again, that's after the function makes the shape, so that is a vertical shift. And a lot of times we're just going to say what it does. It's going to move it up 4. So here's what we're looking for. The shape of the original function normally would have been 0, 0, so we're going to leave that there. But then we're going to make all the points twice as tall. So twice as tall as 0 is 0. And then we're going to go over 1, and we're going to go twice as tall. So that would be over 1 and up 2. We'd normally go back 1 and down 1. We're going to go down twice as far, so we're going to look like this. So this is what it would look like. Okay, we're going to have this steep line right here, and then we're going to take this and we're going to move them all 4 units up. So we're going to go 1, 2, 3, 4, and then we're going to go, again, the pattern would be over 1, up twice as far, back 1, down twice as far. So we've got this right here. So this is what it would look like. Okay, so we've got that shape right there. And again, I'll come back here and I'm going to draw what the original one would look like, just this dotted line right here, perfect 45. You can see that it's been made twice as tall, it's twice as steep as it used to be, and it got moved up 4 units. Okay, let's move on to the next one. We've got the 1/2 out front, and then we've got the -2. So this is going to be half as tall, so we'll say vertical shrink. It's going to shrink it by a factor of 1/2, so we'll just write half as tall. And then this one right here, this is going to move it down 2. I'm not going to bother writing that it's a vertical shift. We can kind of figure that out just by looking at it. Okay, so let's go ahead and take a look here. So the shape of this is going to be a line that's half as steep. So we've got this right here at the origin, and then we're going to go over 1, and we're going to go up half as far. We're going to go back 1, and we're going to go down half as far. Because again, we would normally go over 1 and up 1 full unit, but because of this 1/2, we're going to make all the points half as tall. So we've got something that looks like this. So we're going to take this and we're going to move it down 2 units. So we're going to go down here. This is kind of like the center of the whole shape here. And again, we'd go over 1 and up half as far, back 1 and down half as far. So this is what the line would look like. Again, we'll make that as straight as we can, make that look nice. And then again, the original one on this would look like this. So for comparison, does that look like it was made half as tall? Looks less steep. And does it look like it's been moved down 2? Hopefully it does. Hopefully you can see that. Okay, let's take a look at the next one. We've got a couple things going on here. That negative, whoops, let me change colors again. That negative is going to be a vertical flip. So vertical flip, we're going to flip across the x-axis, top for bottom, bottom for top. This is going to make it twice as tall like we did before. Okay, so stretch, and I'm going to write vertical stretch here. So vertical stretch factor of 2, so it's going to be twice as tall. And then this guy right in here, that's inside the set of parentheses, so that changes the x before it makes the shape. So that's going to move it in a horizontal direction. It's going to do the opposite of what we'd think, though. You would think that this is going to move it left. It's actually going to move it right. So we're going to put down right 3. Okay, so let's come up with the shape here. So again, we're going to start at the origin. That's kind of the center of things. And then we would normally go to the right 1 and up 1. But remember, we're going to make them twice as tall and we're going to vertically flip them. So instead of going over 1 and up 1, we're going to go over 1 and then we're going to go down because we changed directions, and we're going to go down twice as far. So it's going to look like that. And then in the other direction, we're going to go over 1. We would normally go down, but we're not because of that vertical flip. We're going to go up, and we're going to go up twice as far. So that's what it looks like. Now, the only other thing that we need to take care of here, now that we have the shape like this, is we need to take this and we need to move it to the right 3 units. So we're going to go 1, 2, 3. So we're going to go right here, and then let's follow that same pattern. Over 1, down 2. Back 1, up 2. So we have the right shape, and then we'll draw this line right here. So we're going to draw it so that it looks like that. Nice solid line, arrows to the end. I'm going to draw the original one in blue, so we're going to make it look like that. So does this look like it was flipped upside down, top for bottom? Okay, and does it look like it's steeper? Definitely steeper. And did we take this and did we slide it over? So you can kind of see the flip pretty easily here and that it's steeper. And then we just took that graph and we just moved it over there. So hopefully that looks pretty good. Now, the reason we have an asterisk by this is because we can actually write this in a little bit different way. So I want to take a look at this and say, well, gosh, if we were to just rewrite it, what could we do here? So we could write f of x here, and then what if I were to distribute through? That would make this negative 2x, and then a negative times a negative is a positive, so this would be plus 6. So if we look at this in the terms of y equals mx plus b, look at this like a regular old function that we're used to graphing. This would cross at 6. The y-intercept would be 6. Well, look, it crosses at 6, and it would have a slope of negative 2. So down 2 and over 1, down 2 and over 1, or the opposite of that would be up 2 and back 1. So we end up with the same graph as if we were to simplify that. So does it matter? Well, the answer is not really, other than what did they mean? What they meant was what we did up there. So what they meant was this up here. They meant to do negative and then x minus 3. They meant to do this horizontal shift. They meant to mean to take that to the right 3. They meant right 3, and then to do the vertical flip and the stretch. That's the way it was intended to be done. So although you can arrive at it just like this is the best way to think of it, okay? So it doesn't really matter, but it would be much better if we followed along with that. Now, before we do the next couple, I'd like you to take a look here. Again, it's really helpful most of the time when you're getting a sense for what's going on here is to put that dotted version of the original one on there. You can kind of start to see how these transformations take place and how they change the original shape. So we're going to come down here and we're going to take a look at the bottom of the page here. And it says, starting with the parent graph of f of x, describe the transformation that's given below and then sketch the function. Doesn't matter if we use f of x or if we just use plain old y. So you'll notice that we've changed from function notation to just y equals, and it really doesn't make any difference. Remember, those are the same thing. So we're going to take a look at this right here and notice that there are no sets of parentheses. So this is going to be a vertical stretch. So we're going to say v stretch factor 3. That's going to make it taller, and if you need to, let's just write down taller. And then over here, this is going to take that. It's not in parentheses, so this is going to be a vertical shift. This is going to move it down 5. So we're going to take that original shape, and we're going to stretch it by a factor of 3. So normally we would be right here, and we'd go over 1 and up 1. We're going to go over 1 and up 3. We'd normally go back 1 and down 1. We're going to go back 1 and down 3. So there's our shape. And we're going to take this shape and we're going to move it down 5. So we're going to go down 1, 2, 3, 4, 5. So we're going to be right here. And again, we're going to repeat that pattern. So the pattern on this is we're going to make it 3 times taller. So we're going to go over 1, up 3, back 1, down 3. And this right here is the shape. Okay? All right. Now, does that match up with what we normally would think would happen here? Does it intercept the y-axis at -5? It does. And does it have a slope of 3? It does. So you'll notice that we arrive at something that we're very familiar with. We already know how to graph this, but we got there by way of transformations, which in the long run are much more valuable tools than just saying, oh, if we put it in slope-intercept form, then I know what it looks like. Okay, so let's go ahead and do this one. On this one right here, let's see what we've got. This is a 1/3, so this is going to be a vertical shrink. Vertical shrink. The factor is 1/3, and this is going to move it up 4. Now here's what I'm going to try and do. I'm going to try and just get this graph from the get-go. So we're going to move this whole thing up 4 units, so it's going to cross right here. And then we would normally go over 1 and up 1, but this says we're going to vertically shrink it by a factor of 1/3. So we're going to go over 1 and up 1/3. Okay, and then we're going to go back 1 and down 1/3. So it's going to look something like this. So I'm going to draw a line here. Okay. Now, the original one, I didn't draw it on that one because we've probably drawn that enough at this point. The original one looks like this. Does this look like we vertically shrunk it, made it 1/3 as tall as it used to be, and then moved it up 4? And by the way, does it match up with the fact that we know that the y-intercept is 4 and then the slope is 1/3? Again, you can do it either way, but this transformation approach is much, much better because we're stretching and we're thinking using a different part of our brains in order to think our way to the answer. Okay, let's take a look at C. This one has an asterisk by it. You'll notice that we've got a whole bunch of stuff going on here. So I'm going to work backwards on this. This is outside the parentheses, so this is just going to move the graph up 6 units. This is inside the parentheses, so this is going to move it, let's see, we would normally think horizontal. You'd normally think it moves it in the x direction to the left. It doesn't. This is going to move it to the right 3 units. And then this right here, again, does 2 things. So this is a vertical flip with the negative and a stretch. It's going to make things taller by a factor of 2. Okay, so let's use these guys right here to kind of figure out where we've moved this. We've moved this to the right 3 and then up 6. So we're going to go to the right 3 and we're going to go up 6. So that would put us right here. Now, normally that shape would be like this, just a regular old linear graph like this, over 1 and up 1, back 1 and down 1. This is kind of like the center of the whole thing. We've kind of moved where our origin is here. But on this one, we've vertically flipped it and we've stretched it by a factor of 2. So instead of going right 1 and up 1, we're going to go to the right 1 and we're going to go down because it's vertically flipped, and we're going to go twice as far. So we're going to go down here. And then normally we'd go back 1 and down 1. We're going to go back and up because of the flip, and we're going to go twice as far, so it's going to look like that. So I'm going to go ahead and draw this line right here. Do that as straight as I possibly can. So that looks pretty good. And draw that line in there. Does this look like it was flipped vertically? So flipped top for bottom. Yep, it goes down rather than up. Does it look twice as steep as it used to? Yep, looks twice as steep as it used to. And did we take this and did we move it to the right 3 and up 6? So that's kind of like our new center right there. Looks pretty good. Now, could we go through and verify that this does look like what it would look like if we did it in slope-intercept form? So if I were to distribute through here, and I'm going to do this in green, so if I were to distribute through here, here's what we'd get. Negative 2x, and then this would be, let's see, what have we got here? Plus 6 plus another 6. So we'd have y equals negative 2x plus 12. Gosh, and that looks like that probably crosses right around 12, so that would look pretty good. Okay, so we're going to slide down here to the bottom. So on example 5, it says, starting with the parent graph of f of x equals x, so that's just plain old y equals x, just that regular old parent graph, that linear function there. Write the function with the following transformations. So what would the new one look like? So it says translate up 1 and left 2. So we're going to go ahead and write this. We're going to write y equals, and then if we want it to move up 1, vertical changes, we'd have to do a plus 1. And if we want something to move left 3, we've got to change the x. So I'm going to put that in parentheses, and we're going to make it move to the left. Remember, to make it move to the left, we actually have to speed up or make the graph sooner. So we're going to add 2 to that. We do the opposite of what we'd think with the horizontals, and then we're going to do plus 1. So that is it right there. Okay, let's take a look at B. And here we've got a vertical stretch by a factor of 7. Translate down 1 and to the right 4. Okay, so remember, horizontal changes have to come within the set of parentheses. So I'm going to write y equals, and then we're going to take the function x, and we are going to move to the right 4. So to move to the right, we actually have to subtract 4. And then if we want to move it down, we've got to subtract 1, and then we want to vertically stretch it by a factor of 7. Remember, vertical changes, just like the minus 1, they do exactly what we think. So if you want to stretch something by a factor of 7, you've got to put a 7 out in front there. So there's our answer on that one. And then vertically shrink by a factor of 1/5. Again, vertical shrink, this is going to be, we're going to take that original function x, and we only need to do one thing. We just need to vertically shrink it by a factor of 1/5. Well, we just multiply it by 1/5. Can't get any easier than that one. And this last one, it says reflect across the x-axis, then move up 2 and down 3. Up and down. Okay, we're not going to do that at the same time. I think I've got a typo right here. Let's go ahead and change this to left. Okay, so we're going to make that left 3. So again, if we want to make a horizontal change, we have to change it inside the set of parentheses. So we're going to write y is equal to, and then I'm going to have the set of parentheses. So there's that original function x, and we're going to move it to the left. So left, we'd have to add something, okay, because we do the opposite of what we'd think, okay? And then we want to move it up 2. So if we move it up 2, that's going to be a plus 2. And then we want to reflect it across the x-axis. Well, a reflection across the x-axis is going to trade top for bottom, bottom for top. So that's going to be a vertical change. And to make those flips, we just multiply it by a negative. So that is what that one would look like. Okay, now, here's the big idea. So I'd like you to put a star by this. The idea behind this is there's really only one linear function. The only linear function is this guy right here. It's just f of x equals x, or just y equals x. That's that basic linear function that does this, and then every other linear function is just a transformation of that. They've either made it steeper or shorter, they've vertically flipped it, or they've slid it left, right, up, down, or something like that. So go ahead and perform the self-assessment right here, and then get started on the assignment. Lots of good things to practice on this one. Good luck.